Hello, everyone. Welcome. First, kudos to you, actually, that you stayed so long for this last talk and probably for the closing keynote. But I will promise you will have some joy in this talk, even maybe some developer joy. We will see. So you might ask yourself, why is this guy from Atlassian staying here and talking about developer joy, right? We as developers have the best job in the world, right? We already enjoy what we're doing, right? We're writing code that gets us put into software, that gets us used by our customers, which is really great. We have really a direct influence of the success of our software. So why in the hell is this guy from Atlassian staying here on stage talking about developer joy? It is because in the last 10 years, software development have significantly changed. We have changed the way we worked. We have changed, our industry has changed, right? So if you look at that, we needed to learn new paradigms for developing software in the cloud, right? So we needed to learn all these new libraries, AWS, Azure, GCP libraries, whatever you want to call, whatever you use, right? We need to learn this new paradigms, right? And also now our apps are running into, our microservices are running into little small containers, right? Containerization. This is a different paradigm. The first time I spun up a container, I turned it down, got it down after a while, and then I wanted to see the log file, and I realized that if the container's down, there's no log file anymore. So it's just like another way of working in this new world, right? And then microservices, right? Before we had to not worry about just calling another function or another class or whatever. Now we have to just make sure that the microservice is there, that we use the right version of the API, all of these things. And then also security and governance, right? Now we need to just take care of our software to make it secure. It's not running maybe behind this big firewall that we had before with our big monolith that we were running. And then also you build it, you run it. You heard Werner Vogel saying that quite a while ago, right? Now we're not only just building the thing, we are also responsible for running it, right? There's a lot of more observability that we need to add to our microservices, and we have to deal with our tools. We have to be on call, on duty, right? So all of this is actually increasing the cognitive load of software developers. All right, now that we know that, right? People saying, okay, yeah, it's all great, good that you do that. This whole DevOps movement, we love that, right? Quality goes up, you're responsible end to end from the beginning to the actually operational side of things. But you know what? You're not productive anymore. So we need to get back to productivity. You need to be productive again, right? 10 years ago, you crunched out more features than now, right? And you said, duh, right? We have to do all these new things on top of what we have been doing before, right? Where does this obsession with productivity come from? Well, let me take you on a little time travel here. Are you okay with that? Traveling back in time? Okay, we're traveling back in time 126 years. I count to 3, and then we're traveling back. I guarantee you I'll bring you back to 2024 again. No worries. So 1, 2, 3, boom. Here we are. The year is 1898. We are in the Bethlehem Steel Factory. So the Bethlehem Steel Factory had actually some productivity problems. So what they did is actually they couldn't at that time call McKinsey or the Boston Consulting Group or whatever, right, to fix their productivity issues, right? They didn't exist at that time. What they did, actually, they called one person, and his name was Frederick Winslow Taylor. Some of you might have heard of Frederick Winslow Taylor, famous for his taylorism. And this person was supposed to fix the productivity problem of the Bethlehem Steel Factory. So the first thing that he did was actually he pulled out a stopwatch and just looked at the factory workers, how they were working, what tasks take what time, right? So that was the first thing that he did. Then he saw just like, okay, if we arrange that group closer to that, optimizing a little bit like the workflow in this factory. But the next thing that he actually recognized was the workers were shuffling coal, right? They were shuffling coal with normal shuffles that was made for shuffling soil, actually. So coal was falling left and right from the shuffles. So what he did was he gave the workers custom-made shuffles to improve their productivity, right? So they could shuffle more, right? So custom-made shuffles. Tooling has something to do with productivity. But not only that, he also recognized that the workers could carry more in the morning than in the evening. Obviously, right? Yeah, you get exhausted, you can't carry that much anymore. So what he gave the breakers was, the workers was more breaks. Breaks in between, right? To just like recover a little bit. So during the whole day, they could carry actually more by doing that. So he just like did a lot of other stuff. He really optimized the hell out of this factory and increased the productivity of the workers by 400%. Boom, right? Amazing, right? But everything comes actually with a flip side. So he also introduced new roles into the factory, right? The workers were now doing only repetitive tasks. Everything was all optimized. They weren't supposed to think, but he just like brought in more managers to do the thinking, to do the optimization, to do the thinking, right? Sounds a little bit familiar, right? No? Okay. Anyway, this is 126 years ago. And I sometimes feel like we are falling back into this age where we just like think like, okay, we can optimize here and there the flow of software developers and optimize the developer productivity. Okay, I bring you back to 2024. Let's talk about today's developer productivity. I hear a lot that people are still doing this here, counting the lines of code, like how many lines of code have been added as a measurement for productivity. We did actually a survey, and this was the thing that most of the organizations were doing, because what should they measure, right? That's an easy thing. Actually, my manager, when I first started, he actually said, Sven, how many lines did we add in the last quarter? Like, I need to report that to the management so they see we are just like making progress and we're adding more lines of code and more functionality. Well, that has nothing to do with productivity. We all know that, right? So what else can we do? Yeah, how many issues we move into the done column? All right, yeah, that's maybe a better measurement, right? But we all know that there are smaller and larger issues, so maybe not a good measurement for how productive we have been. Then you say, oh yeah, but we just like have story points on that issues, right? So we can just like use the story point as a measurement for productivity. Story points are estimates, right? I can estimate this is a big story and then get it done in 1 hour, or I estimate, oh, this is an easy one and get done it in a week. That doesn't tell anything about productivity, right? Even our t-shirt sizes to make it easier. But we found some stuff that might work, like cycle time or deployment frequency and all this kind of signals. Well, guess we have found the best, the productivity measurement, the one metric that measures productivity. What our managers will do then is say, okay, we need to get faster, right? We need to have 10% more story points or 20% faster per request. Just like, thank you very much, Frederick Winslow Taylor, right? Still, we are thinking in Taylorism times, in Taylorism terms, right? And it's because we know this has been working, right? It has been working for factories, so why doesn't it work also for software development? It doesn't work, right? So a lot of people are now talking about, instead of developer productivity, talking about let's increase the developer experience, which I think it's a great term, right? Let's increase the developer experience to make the developers faster. But But also here, there are some consultants that are smart enough to sell you some developer experience optimization training, right? And they show you this nice little flowchart where they just like, if you squeeze here a little bit and there a little bit, your developer experience will increase, right? Or McKinsey that has this here, right? Just like, again, their story points actually still in that one, right? Got bad press for their developer productivity measurement or thing here. So what we said at Atlassian is say, okay, let's take it one step back. Developer experience can be good or bad. Let's call it developer joy. So bring back the joy into the craft of software developers. But what does that mean, the joy, right? When do we enjoy our work? When we do enjoy our work as software developers, right? So I have three categories here. The first is I enjoy working on great quality code, right? Code that is really, really great, that when I open the IDE in the morning and say, wow, I love this code. This is when I enjoy working with these kind of quality code, right? Then also, progress. I have an idea on Monday, I implement it on Tuesday, I deploy it on Wednesday, just like things are running fast through the pipelines. I grab something, I can deploy it very, very fast without any friction from other teams. Then I actually enjoy my job, right? And the last thing is I'm delivering value for the customer, right? I'm delivering the right thing that the customer wants. Right? And the customer says, Sven, I love your software, right? I'm feeling proud of what I've been doing, so I'm delivering great value to the customer. And guess what? If all these three things come together, you might also say you're productive, right? You're really good in delivering software with great quality, with great speed, and the right things fast, right? So I brought some stories with me from teams at Atlassian, how they increased fixed their developer joy, actually. The first thing is about quality. When we think about quality, what comes to mind? How can we make the quality better? How can we improve the quality of the code, right? How can we actually say it is quality code? It's through code reviews, right? And I hope you're doing all code reviews. You're doing all code reviews. Can you just like, yeah, I see. Everyone's nodding. Yeah, okay, yeah, okay, good. Thank you very much. But there is something with code reviews, what people really are hesitant to do code reviews. And it goes like this. So assume I have added these just like easy lines of code here, put the pull request out there, add a few reviewers, and say, hey, can you please review my code? And the first comment that I get is this one here. I say, oh God, right? What is this person thinking here? But yeah, I'm a polite person, right? I say, what do you mean, right? Just like tell me, what does it mean, right? And then this person comes back to me and says, hey, Sven, this code looks ugly. And say, whew, I'm done with code reviews. I don't want to put out my code anymore to my coworkers. But also here, I say, hey, I want to learn, right? So why do you think this code is ugly? And the next thing I get is, it would have been nicer if you'd use a for loop, right? And as I said, yeah, the while loop is working. What do you mean by nicer? Explain more about it. Just like 4 words for these kind of people, if they are in the audience here, that does these kind of comments, don't be a jerk, right? Don't be a jerk when you're reviewing code, right? So who has been bullied by a jerk, let's say, in the last 2 months or so? No, don't raise your hands. I know your coworkers are in the room, so it's fine, right? Yeah, but these reviewers are actually the reason why people don't like code reviews, right? Why people just like are hesitant to put their code out there or feel just like bad about putting their code out there. So the Jira team, I don't know if they had the problem, but they wanted to avoid that kind of behavior in software developers. So what they did is actually they looked at it and say, hey, you know, the reviewer, they're in this protected bubble, right? They can just like throw things and they are protected. Well, it's the author that we need to protect, right? That is opening up their work. So how do we protect the author? So they set up some rules for code reviews, and the first thing is assume competence, right? we're doing a lot of interviews with our software developers before we hire them. So these are competent people, right? They have studied, they have written code maybe before, whatever, right? We actually assume that they are competent people. They can write good code. That's the first thing. The second thing is be constructive in your feedback, right? Just like don't say, this code looks ugly, right? This is not really constructive, right? I want to know, I want to learn also from this. And the last thing is also explain your reasoning, right? A for loop would be nicer. That's not the reason. So explain me why a for loop would be nicer than my while loop that I point out there. So the thing is, they wrote all the rules down, also actually rules for the authors to say just like review the code yourself before you put it on a pull request and get your coworkers look at it, some things like that. But they wrote everything, all the rules out there. And once people are just not following that etiquette here, they can point it out. They can say, hey, we made this, right? Just like this is important for us as a team. So better reviews, right? Less mean no bullying or less bullying, and more developer joy at the end, right? We even enjoy code reviews. Okay, the next story is from the Confluence team, the team that builds Confluence. So the Confluence team actually, after you just like have your pull request done, you merge it back into the main branch, and then of course automatically a test kicks off, right? So, and sometimes it happens like this, like the test turns red. It's not live, it's not end of life, right? We just like know, okay, great, we have this test and it caught a bug. That's good, that's good. So you just like open your IDE, you look at the changes that you made, and then you look at it again, and just like after 20 minutes, looking at it and say, I can't really see. You look at the log files, you look at the code and say, I can't really see why this test really fails, right? Why does this test fail? I don't understand it. What are you doing as the next thing then? Yeah, I just like say, okay, let's like rerun the test and see what's happening. And then the test is green. Boom. Okay, done. Great. Everything is fine again. Cool. No. You just discovered a flaky test. So you have to do something with that. Oh, it's 70 minutes out there. It's time for a commercial. I'll be back after the break.
Is seeing red build after red build getting old? Is rerunning your failed jobs getting you down? Is waiting on those failed jobs to finish making you crazy? Deterministic reliability is here to help. With our handy-dandy flaky test monitoring system, we will, eventually, automatically bypass those flaky tests. For 4 easy payments of free, you too can save time, ship quality code faster, be more productive, feel so much better when you go to work every day. You will be happier. Your team will be happier. You'll stop dying inside. You'll stop banging your head against your desk. You'll stop replacing computers that are in a rage against the wall. Sorry. It's just a little close to home. Call 1-800-ATLASIAN today to get your free flake monitoring system.
Don't call. We don't have a product out there that catches your flaky tests. It's actually internally built by the Confluence team. And they made this video to just like spread it out to the whole Confluence engineering department to just like that they can also use this great flaky test detector. So flaky test detector, very easy if you want to rebuild that. Once you create a pull request, actually the build and test kicks off, right? And test fails. Flaky tester says, that's just like let me try to rerun the test, and then the flaky tester reruns the test a couple of times, and then if one of these couple of times the test passes, right, the flaky test detector says, I just discovered a flaky test. How great, right? So what I do is just like I mark the test as skip test, so it's not going to be executed anymore, and then also I add a comment to the pull request automatically that the team actually can look at it, and there's also a message on Slack, so the team knows actually that they have to look at this flaky test and fix it, right? Sometimes the code is also flaky, so you have to fix the code. But it helps the team tremendously. They actually implemented that, and it saved them. It caught in the first months, caught the whole. I think 10 teams are using it. Caught 15 flaky tests. Right? It's a lot of engineering hours that we saved with the flaky test detector, and a lot of frustration from developers that looking at the code and just like don't find it and rerun the test and then find out that it's flaky, which means at the end, increasing developer joy, more developer joy, right? Developers love to be in the flow. It's me, I love to be just like in the coding phase when I'm just like thinking classes, abstract architecture, everything is in my head, it's getting dark outside, I don't see that, I'm just like coding, I love this flow. Unfortunately, software development is not only about that, it's not just the coding phase, there's a lot of more involved in software developing, like the build and test phase and the deploy phase. So we need to optimize for that, right? So that code flows quickly through the systems. And you can just like optimize the build and test phase from hours to minutes, parallelize your tests, get more CPUs to test it out, whatever. Or the deploy time builds more microservices, just deploy a microservice, don't deploy the whole monolith. So you can just like optimize it so this time gets shorter. But there's one phase actually that takes a long time, and that is the review phase. It can actually take days until someone has reviewed or everyone has reviewed your pull request, and you can just like move on to the next stage and merge your code back to the main branch. So the Confluence team also has discovered that it takes too long, right? So they were actually measuring it, and on average they had 3 days on average from opening, right, pull request to merge it back to the main branch. 3 days of just like the developer working on something else, coming back to the code and need to remember, what did I do, right? What did I do 3 days ago? Just like fixing things and then merge it back, right? So actually the team lead was looking at that, of that team. If you have all the open pull requests, he was just like looking at who are all these reviewers that are sitting there, and his name is Punit Arora. So Punit was just like saying, okay, we have to do something about these open pull requests. So I'm just like in the morning, before everyone gets to work, pinging everyone via Slack, saying, hey, there's an open pull request. You might have missed the notification, which is fine. It's fine, right? There's so much stuff going on during the day. It's good. But before you go into the flow phase, before you start coding, right, can you please review that pull request from your coworker, because it's super important that also your coworkers can move on. They also want to get speed, right? So please take the time and review that pull request, right? It helps the team tremendously to just like review pull request faster by just having a ping in the morning to just like a reminder of there is a pull request out there, look at it, right? And then the team said, okay, Punit, we know it's not your job, right? So we replace you with a Punit bot, right? A bot that we call the Punit bot, and the Punit bot is now pinging everyone in the morning saying, okay, there's an open pull request. Not only that people are reviewing pull requests faster, they also learned about just like why they didn't want to review the pull request. They open it, some people open it, and then it was way too long, right? And they closed it again and say, I'm doing it at a different time. So they learned that they have to make the pull request smaller, the amount of changes smaller in a pull request. And they went down from 3 days to 1.2 days, right? Really good improvement, still room for improvement also, but already 1.2 days better than 3 days, right? For the team, it means less wait time, right? Waiting for others to review, less friction, and more developer joy. Flow is important, right? In the team, pull requests, all the things, right? Flow is important, that things flow fast. I'm obsessed with flow. But you also need, not just in the team flow, what's even more is you need a frictionless flow between teams, right? So let me show you. I compare now software development with a little bit a traffic system here. So let's assume you have to work together in different teams, and then you don't have any rules, right? You don't have any processes, like at this traffic junction here, right? There are no rules, no processes. People have to find the way, right, in this junction. And this simulation says there are 191 cars per minute that can pass this junction. So let's add some processes, right? So what can we do, right? Let's add some traffic lights. So some cars can go with full speed while others have to really stop and wait. So also this simulation is done and says just like we have 235 cars that passes the junction in a minute. Well, it's an improvement, right? So, but it's really frustrating again, right? If you do that, because you're just like stopping, you're waiting for other teams to just like do the work. They can go full speed, and then once it's your turn, you can go full speed. Okay, that's probably not the best thing. So let's do something more that has a better flow, actually. So let's take this one here, a roundabout. And you can see just like every time there is a slot free, work got slotted in, right? Or the cars got slotted in. That's a little bit more the agile way of working than when the design team has time to just like do the design, we slot it in, it goes into it, flows through the systems, right? Traffic flow here is 360 cars per minute. Well, we're improving, right? Great. So agile is the way to go. But wait. There's one more. It's called the stack interchange, right? And you can see no car is actually slowing down here. Everyone. So they merge magically into the lane. They don't have to slow down, right? And traffic flow is 1,099 cars per minute in this stack interchange. But what does that mean for software development if we work with teams, different teams, right? So they don't have to wait for other teams or for other cars here. And it's making your teams as autonomous as possible. So you don't have friction between teams, right? Of course, yeah, if I show this to a CEO or CTO here, right, this drawing, like, I don't like this wavy lines, right? Teams are just like flowing around, right? Of course, yeah, okay. These autonomous teams need to be aligned, highly aligned. But what does it mean, right? Cross-functional, autonomous teams, where we have all the functions inside the team. We have designers in the team. We have QA in the team. We have ops people in the team. So the team can run at their speed, which is great, right? Awesome. In theory, it's awesome, but we ran quickly into the problem. Actually, the Trello team had that problem. So we're looking at QA people, right? Have a QA person on the team so they can just like review all the new features directly, so we can just like ship them automatically afterwards, right? And then we looked at the ratio of QA engineers to developers, and it's a 1:30 ratio. We don't have enough QA people to put it in every team, and probably there's not enough work for a quality engineer in every team full time, right? So what should we do, right? So we were looking at, okay, the developers are already writing automated tests, right? And then the QA people are doing exploratory or manual testing the software that everything is all right. Well, we moved that task on to the developers, actually. So the developers are doing the whole testing period, right? So they don't have to wait for a QA engineer to do the job. And it's called quality assistance. So quality assistant is actually the way we go. So we're doing QA kickoffs, right? So we don't just like leave the developers alone, but we teach them actually. So they take responsible of the quality of the software. They don't throw it over the wall to the quality engineer. They will just like find all the mistakes in the software or the problems in the software. The developer is responsible for the quality. So QA kickoff works the following. Before actually the developer starts implementing the code, they look together at the user story. So they have a session, quality engineer and developer, and they write down a test plan, how they would test it. That way, actually, you have a ready test plan. So once you implement it, you have a test plan, and the developer learns to think more like a tester, how to test the quality. So they're doing this actually before they implement it. So they implement the code, they They do the manual testing, run through the test phase, the developer alone, and then they deploy the software without any QA engineer involved anymore, which is not 100% true. There's a demo where you can just like look at what the developer has been doing and can intervene. I will talk about that in a sec. But it's not the only thing that the QA engineer, that the QA department, the quality assistant department is doing. They're also helping, if there's a bigger feature that the team develops, they're also helping to blitz test a feature. So blitz test is the whole team comes together and tests the hell out of a feature. Right? And then someone, like a QA engineer, is collecting all the feedback, right? And saying, okay, this is something that we need to fix before the deployment, and this is something that, yeah, it's not really super important that we fix it before the deployment, so we got things out. So this is what how the QA team is actually helping the development team to do some blitz testing, and they are also building the test environment, test databases. This is all the responsibility of the quality engineering department, not of the developer. They can actually use that. It means that developers lower the cognitive load, right? So less cognitive load on the developer side because the quality engineers taking over a lot of the more heavy lifting and more developer joy, but still we have speed in that system. All right. Another thing I want to talk about is this here. And it's a little bit like sometimes when you talk to product managers, they live on different planets, it feels like. They have different language, different lingo, and it feels like weird, right? But somehow we need to work together with the product people, right? We need to understand the requirements, all the things. So true story here. I once actually was implementing a feature that a product manager gave me, and the product manager wrote this user story here. As a user, I want to export data, so I want to have it in an Excel file. I said, easy way, easy thing, right? I just like export the user data into an Excel file, right? I just like grab the library, done, right? Okay, cool. I gave that to the product manager to say, is that what you wanted, right? And then said, yeah, well, not really. I actually just like don't need all the data from the user, right? Just like a subset of the data. That's too much data, right? I don't want to know when it's when it was created, all the things. I said, okay, good. Tell me what's the important data, right? So we rewrote the user story to, as a user, I want to export the important data so I can have it in an Excel file. Great. So I did that, just like a few just like columns in that Excel file. Great. And I gave it to the product manager and said, is that what you wanted? And they said, yeah, nearly, but I didn't know that there's a difference between an Excel file and a CSV file. So can you make it in a CSV file, please? Okay. Okay, good. So as a user, I want to export the important data so I can have it in a CSV file, right? And then this person came and says, wow, brilliant. That works brilliantly. I export the data now, right? And I put it in a CSV file, and I put the CSV file into our CRM system, upload it, so I have the data in the CRM system. So I said, what are you doing, right? What? I mean, there's an API in the CRM system, so I could just like use the API, right? Frustrated. So this reiterating over things, right? But the requirements wasn't clear. Everything was fitting in a small user stories. But I don't want to blame the product people, right? They're doing great job. They're doing a lot of research, measurements, interviews, experiments. They're building maybe prototypes, right? And then they're just like, sure, this is the thing that we should build for the customer. The next thing is they squeeze it into a small little user story, right? And then we should build the running software, right? We should just like assume all the things that the product people did, right? So the Jira team, actually, they were just like saying, we need to find a way to work better with the product folks on that. So we need to find a way to do that. So how can we just like work better hand in hand, product and development? So they were looking at the phases that people were going through. And developers were actually, they were responsible for the make phase, right? Just like create the software, we're just like responsible for the make phase. Where the product people were responsible for what we call the wonder phase, right? Just like what is the problem of the customer? Where there are more phases actually, there's also the solution phase. Once we identify the problem, we need to find the right solution. Sometimes we are starting with the solution phase, right? We just like we already know what the customer wants. No, we need to start with the problem phase. But then there's also a gap, just like on the slide here. So there's one phase more, and this is also sometimes what we're forgetting. It's the impact. So that we need to improve the software. What impact does it really has? So we need to measure. Is that really what we wanted to build? Is that successful what we've built? Do we need to improve something? And guess what? Developers need to be involved in all those phases. We're not 100%, right? We don't want to take over the jobs of the product managers, but we need to be involved in, mostly, of course, in the create phase, less in the problem phase, maybe also in the solution phase, and definitely in the impact phase to know how our software gets used with our customers, by our customers. Where the product people are probably more involved into the problem phase, also the solution phase, and then also at the end again, just like seeing, is that the thing that we just like solved? Did we solve the problem of the customer because we laid it out, right? So we're just like having some milestones in here. So we say, okay, we're doing a project kickoff. So everyone comes together. Product people, IT people, designer, ops people, QA people, everything comes together to know why we are building this new feature. What are the reasons why we're doing it? So we can ask questions to the product people. So we know something will be coming in the next 2-3 weeks or 4 weeks or 2 months, whatever. And then we are also involved in this explore phase where we just like looking at prototypes, right? So the product people, they probably, or the designers, the UX designers will probably build something in Figma, but we also need to see, is that technical feasible? So we just like get involved into that too as software developers, but also as software developers, they need to just like also report to everyone else in the product cycle, right? So they just like run regular demos. And then in the impact phase, we also have to be involved in that. So because we are all software developers, let's talk about the demo phase here. So we're bringing everyone, this is just like a picture from the past. We work distributed. It's normally a Zoom call when we're doing our demos. We're also going for async. We're experimenting with asynchronous videos now to record just the demo. But right now, Zoom calls are the way to go, less like video calls. So it's important. We have some rules for the demo sessions. First, everyone can join, right? It's not an invite. It's just like, it's an open thing. Everyone can actually join the demo session. I can join every demo session that our software teams are doing if I want, right? So designers, product managers, everyone is in there. Then it's outcome driven. So we show the customer value. No implementation details, no problems about just like the coding, the database, whatever. It's about showing the customer value. What is the customer value that we created in that 2 weeks? And then we discuss, we challenge the solution. We see, is that really what we wanted? Is that really what we have at the end right now? Is that really the thing? So, and sometimes the product people come in and say, oh, wow, now that we see that, maybe we take it a step back and show it to the customer first if that's the right thing. So we're just like cutting corners here. We just like don't build a thing, deploy it to the customers. We just like have the product people involved before. And then also once we are all in one call, we celebrate wins. If we just like already deployed a milestone, right? We're just like sitting in one call, so we can also celebrate together. We are all in this together. We build this software together. We build this feature together. Everyone involved, right? Which is great. So involving everyone means less rework frustration, right? So we just like, everyone is there. QA is sitting in there and saying, have you tested this, right? So we don't. They are also involved in that. Less rework frustration and more developer joy at the end. Now, these are just like a couple of stories that I wanted to tell how developers take themselves, right? Take the responsibility themselves and fix the way they work. But you might say now, what will the good old Frederick Winslow Taylor say, right? Where are the measurements, right? Do we really improve the productivity with these things? What would Taylor say, right? Is that better now that we work closer together with the product manager? Might be nice, but does it really improve something, right? It was not Frederick Winslow Taylor, but it was Peter Drucker who said just like, if you can't measure it, you can't improve it. So where do you start with measuring, right? Where should we start? What should we measure? So a good thing, just like industry practice these days, when you want to start with something, you should start looking at the DORA metrics. If you heard about that, it's these more operational side metrics, so more outcome metrics that what goes out of your software development. But I would also recommend that you just like think first before you implement the DORA metrics. I just like talked to a couple of CTOs who said, "Oh, we implemented the DORA metrics and rolled it out to all the teams." And said, "How did it go?" Yeah, teams didn't use it because it wasn't their problem, right? They weren't looking at it. So just like think about it. What's important for your team, right? Where does your team struggle? What does make sense for your team? Some teams may have problems with the build time, right? So just like measure that, optimize that, right? Some teams have problems where maybe with a tickle cycle time, and then see just like what are holding us back here, right? We use actually our own developer experience platform, Campus, for that. So you can see there's DevOps health. And sometimes the DevOps health looks like this, right? Deployment frequency down, boom, it's going to be red. It's just like crossing the baseline, actually. So we need to do something. Or do we, right? Because this is just a number. It's just a number, right, that's going down. It can have different reasons. We may not have a problem if the deployment frequency goes down if we know that half of the team is sick, right? So we need to always add context around that numbers, right? So we are running a weekly ritual called CheckOps. So it's just like we're looking at those numbers and talking as humans about it. So we are adding context around it, and then we are also looking at what incidents happened. Can we just like see some correlation here, right? And we can do that right in Compass. We can just like document everything that we do, right? So I told you we are just like having team metrics. Whatever is the problem with the team needs to measure that. But it's not 100% true. There's one metric that we are measuring actually on a global scale, so the whole engineering department should measure that. And it's this, right? How much time does a team spend on changing the business, right? Building new features for the customers. So it is this. That counts, right? How much time do teams have to actually do that? This is very important for us as a business, right? But it's not, we're not just spending time on changing the business. The other thing would be just like how much time do we spend on keeping the lights on, just like running the business. And we just like give teams a little bit of a guidance. We say, okay, you should use at least 55% of your time on changing the business. That's the minimum that you should do, right? And the maximum for keeping the lights on is 35%. So meetings, infrastructure, CI/CD pipeline, all the things, like 35%, not more than that, right? And it's different probably from team to team. Some teams just like spend 5% of the time on keeping the lights on, and some teams are just like closer to the 35%. But it's maximum 35%. Now, you must say, Sven, 55 plus 35, you haven't really been good at math, right? Right. But there's 10% left, right? What are we doing? You all saw that, right? People have 10% of their time to improve their developer joy, right? To write these punit bots, to write flaky test detectors. This just like what we give our developers to just like, and it's important for us that people spend that. We are measuring the developer satisfaction and see if that increases. So it's important for us that we give people this 10% of the time. And as I said, we're measuring that. So this is a dashboard that we use here at Atlassian Analytics, where we can see actually how much time each team spend on a product base or organizational base, how much time people spend on that. So all this measurement, right? GitHub that did actually an experiment with their engineering organization. They called it the Good Day Project. In the Good Day Project, they looked at how good, they asked the developers at the end of the day, how good was your day? How productive was your day, right? And, you know, sometimes you feel just like very productive, and other days you feel just like not so productive, right? And then they just like try to correlate that with some numbers that they saw, like activities per day, how many pull requests, how many lines of code, blah, blah, blah. And they couldn't find a correlation, right? Poor Octocat, right? Because software development is not going like this, right? Some people have that in mind. Okay, you have the idea, the plan, the code, the deploy, right? Seems like a production line here. Frederick Winslow Taylor, back to Frederick Winslow Taylor, right? We need to optimize the planning phase or the code phase or the review phase, right? It's not, right? We don't build the same car every day. Software development is not a production line. It's a creative process. Sometimes we just everything is new, right? We just need to create something new. It's a creative process. So we don't build the same car over and over again. We build different things each day, right? And it's new. So measure what's important, but don't make important what you can measure, right? Measure what's important. And how do you find out what is important, right? What is important that we need to measure to improve the productivity or the developer joy or the developer experience, however you want to call that? How do you know that? How do you know that? Well, the answer is super simple. It is ask your developers. They know actually what they are struggling with. So this is actually where we start things. We are asking the developers, right? Where are you struggling with? We're doing a so-called developer joy survey. So we're asking these things to the developer. How satisfied are you with your speed to ship quality code? How satisfied are you with your waiting time, right? Waiting for other teams, waiting for the build or whatever. How satisfied are you with your execution independence, right? Can you execute independently? Your access to tools, processes, and practices. Do you have the right tools, the right processes, the right practices so you can move forward fast? Effort of managing external standards like security and governance. Is that holding you back or are you satisfied with that? Managing your code pipeline and infrastructure. How much time you spend there? Is that okay for you? And then also, if we got new developers, how about the ramp-up time for new developers? Is that fine? And that's an important score for us. Like, how are you satisfied as a developer, right? So I want this a little bit interactive here. So I want you to just say, scan the QR code, or you go to menti.com and enter 15209129, and tell me, what is at the moment, your biggest developer challenge from these options here? Is it speed to ship quality code? Is it waiting time? Are you waiting too much? Right? Is it execution independence? You depend too much on other teams to get stuff done. Is it your access? Do you have the right tools at hand, or you're missing that, right? Or the processes and practices are holding you back? Is it the external standards like security and governance, or is it the code pipeline infrastructure that's holding you back, that you spend a lot of time, right? Or is it just like ramp-up time? Are you unsatisfied with that? Is that your biggest challenge? Or your developer satisfaction overall, right? Give me your biggest challenge here, and we just try to see if we can see the results. All right. Okay, speed to ship quality code, and I think the first three ones are pretty much close, right? It is wait time is probably the number one thing. Actually, I've been running this at a lot of conferences, and this is always what I see. Is wait time is the number one thing, actually, in Europe. Execution independence, a little bit, right? Too much dependency on other teams. And the other ones are just very, very much the same, but it seems like wait time is the number one thing here. All right. Thank you for this short little experiment. So, what we do is we're asking how satisfied are you with that, right? And then it's on a scale from 1 to 10, right? We're asking this on a scale from 1 to 10. But it's, as I said, just teams are different. So we're not asking just are you satisfied with this? We're also asking, how important is that for your team? It might be that you are satisfied with the ramp-up time, but it's actually not important because you don't put on new developers every week or so, right? It's not really important for your team. So from these two measurements that we're doing, we're calculating a so-called opportunity score, and we're adding a traffic light system to it. So if you can see just on this axis satisfaction, just the higher it is, the more satisfied are people with it, and then on the x-axis we have the importance. And if you're in this corridor, right, we think okay, it's okay, right? It's a good balance between importance and satisfaction. But if you're just below that area, right? If you're below that area, then we say, okay, we have to do something. It seems to be important for your team, but you're not really satisfied with it. So these are actually the things you should look at. You should find some measurements that can just like, or signals that can signal that and try to improve it, right? And see if you can just like make this number better. So we are running this developer experience surveys. We have run that monthly. Now we're running every 2 months. Developer satisfaction score went up. And we wrote everything around this developer experience survey. It's free. It's a free resource. You can just like look at that. It's a step-by-step guide how you run it. It's in our team playbook. If you want to go there, go atlassian.com/developerjoy. You will find that it's as I said, it's a free resource to use and no tools involved from Atlassian. But the thing is, once you identified your challenge and you have your measurement in place, the next step is to try to fix some things, right? Try to fix your software developers. Try to fix your problems that you have in your team. And then also, as I said, teams are fixing their own problems, but it might be also a problem from another team, right? Punitbot might be a problem for another team too, right? That no one is reviewing, or that they have a too long pull request cycle time here. So you need also to spread the learning. As I said, Punitbot, they wrote a blog post, and we are blogging a lot at Atlassian, so it's in our internal Confluence instance. So they wrote a blog post about the Punitbot, how you use it, what it's doing, how it helps the team, and so on and so on. And now there are around 20 teams at Atlassian that use the Punitbot on a daily basis. Some teams have used it and said, okay, we get it. Right? We're doing it every morning. We don't need this reminder. It's fine. It's embedded in our team culture. Great. We don't need that. But another teams need this reminders, right? So, summary here. Take your measurements and your survey result. These are two important things, right? Give those also to your autonomous teams. It doesn't make sense if you just like run the survey and just like keep the data anonymized like somewhere with you as a management team or something. Give that to the teams, to the autonomous teams, so they can actively fix their own problems, fix their own challenges, and improve the developer quality, the progress, or the value that they deliver, that this team delivered that your team delivers to the customers. And I also always wanted to do a Venn diagram in my talks, and here it is, right? Because right in the middle there, right, there is actually where developer joy is happening. When you work with great software, when you have great progress, and you build the right thing for your customers, you actually enjoy what you're doing, right? We all became developers for a reason, because it's fun. It's great to develop software, to write some code and give that to the customers, just like deliver value directly to the customers. So don't forget to have fun, and thank you very much. Enjoy the rest of NDC Oslo. Thank you.